Okay guys, today we're going to talk about the end behavior of the functions we talked about yesterday. So take out your notes for 5.2. And again, objective students will describe the end behavior of any given function. Okay, so if we could recall the shapes of yesterday, if you look on the left side of the whiteboard, I have linear, remember that was a straight line, a cubic, a quintic, whoops, sorry, that's not quintic, and a quadratic is a parabola, and a quartic. So I want you to take a couple minutes and try to predict with your partner what would your graphs look like if the leading coefficient was negative. Remember that with a parabola, if I have y equals positive x squared, that would be a happy face. If the leading coefficient was negative, that would be a sad face. So take a couple minutes, or I'll give you about a minute, to try to predict how these graphs would look like. And then we're going to get into the end behavior. So go ahead, take about a minute. Okay, that was less than a minute, but you can see that if it flips. So for a linear equation, it would go downhill. A cubic would flip. A quintic would also flip. A quartic would be like an M. Okay? So we're going to describe the ends behavior. What happens at the ends of the graph? What happens at the ends of the graph? Notice that all the ones on the left, the linear, cubic, quintic, they all have the same end behavior. What do you guys know about these functions? What about their degrees? Their degree is odd. They have odd degrees, x to the first, x to the third, x to the fifth. So all odd degree functions, they have the same behavior at the end. What about a quadratic and a quartic? Well, it's an even degree. So all the even degrees, x to the second, x to the fourth, 6, 8, 10, 12, so on and so forth. They have the same behavior at the ends of the graph. So today we're going to focus on how they behave.